Hello everyone, welcome to the world of data structure. Our today's topic is binary tree traversal pre-order. Hi, this is your instructor Janice Shah. So let's start with outlines. See, here you can see our outlines are pre-ordered traversal in binary tree. Now, students, in our previous sessions, we have already seen that how can we do in-order traversal in binary tree. Okay, in order in which we just first do go on the left side, then visit the node, and then go move towards the right side. See, here that's a pre-order. It means V, L and R. Fine. Now, suppose question coming in your mind that, sir, what do we mean exactly by traversing? So we already know that traversal operation, that means to visit each and every node of data structure at least once. Okay, so here we have the pre-order VLR where we need to visit first node, then move towards the left and then move towards the right side. Suppose if I'm taking an example of a classroom of 30 students, okay, where 5 rows are there, where each row contains 6 students. Fine. So what I'm doing, that if I want to check notebook of each and every student, that is the operation known as traversal operation. Why? Because I need to visit each and every student personally, okay, check his notebook and give the comments in it. Okay, so that is the best example of traversal operation. Fine. So here, suppose in such situations, if I visit a node or visit a bench from left to right or from top to bottom, okay, or from first to last or from last to start. So such type of various techniques, that how can we visit students, or how can I access the nodes of the students. Fine. So same like that, here the traversal operation have the different ways. First we have already seen, that is in order, and now that's a pre-ordered traversal where we need to do visit first, then do left and then go on the right side. So here this is the tree. Okay, it is same as the previous examples like AOF, then PLJG and HEQ. Fine. So what we need to do, very first step to start any traversal, what should you need to do is, you just need to note down or write that VLR, LVR, all LRV on above the nodes. Fine. So on each and every node I'm just writing VLR, VLR, VLR. Fine. So why I'm doing this? Because after writing VLR, it is very much easy for me to perform the operations on it. So here first we need to visit the node and then start the further operations. Fine. So let's start. So here I'm just writing the answer line. Now my answer is first is empty. So let's start with the root node first, students. What operation we need to perform is, that is visit the root node. Okay, so visit the node. So whenever you're doing the visit operation, you just need to write that node into the answer bucket. Fine. So I'm just visiting the first, that is root node. So just cut down V, visit A and write down the A in my answer bucket. Fine. Now the next thing that I need to do is, next operation on A, that is L. L stands for now you should go on the left side of A. Okay, so here we can easily say that on the left side of A, that there is a node O. Okay, so cut the L and then move towards the O. Fine. So for O, what is the first operation? Okay, it is already written over there. Students, you need to do visit first. So just do visit. Okay, so cut the V, visit O and then write down O in our answer bucket. Okay, so here it is. Fine. Now the next is L. Next is L. So we need to go on the left side of O. So before moving, make sure you have to cut L, because after come back or after some of time, you will realize if you don't cut L, it might be possible that you just forgot to perform that operation. Okay, so always remember this, you have to cut line first or you have to cut that operation first and then need to perform it. Okay, so here we just need to move from the left side of O, so just cut L and move towards the left side of O, that is P. Okay, so here it is P. So first we need to visit P. So I'm just cut V, visit P and write down in the bucket, answer bucket. Fine. So next, now tell me, next operation that we need to perform, that is L. Is there any node on the left side of P? Yes or no, students? Is there any node on the left side of P? Just watch in the figure. Yes or no? No. That means there are no nodes. So we just need to take the next operation. So the next operation, that is R. So I'm going to cut R and then move towards the right side of P, that is H. So very first operation that I need to perform is visit H. So I'm just doing visit H and put into the answer bucket and then move forward to the next operation, that is L. Okay, that means is there any node on the left side of H? No. Is there any node on the right side of H? No. Students, here left and right side of H is already emptied just because it's a which node? It's a leaf node. It's a leaf node. We all know that the leaf node, that means a node that does not contain any child node. Now, can anyone from you tell me that, sir, what do we exactly, what is the degree of that H node? What is the degree of H node? That is 0. So that's another definition for the leaf node. If the degree of H is 0, if the number of subtrees of node is 0, if number of child is 0, then it is known as leaf node. And always remember that number of child is equal to number of subtrees is equal to number of degree. So all three terminologies are related with each other. All three are the same. Fine. If I ask you the number of child, then answer is same. If I ask you for the number of subtrees, then it must be same as number of degrees. So, okay, so just take a pen and note down in your notebook that number of subtrees is number of child is equal to number of degree of a node. Fine. So now the next is, there are no right subtree or right child for node H. Okay, so let's move further. Now tell me, here V, L and R, all three operations are successfully done. So what you need to do is, you just need to get back to the parent node. Our parent node is P. Fine. So we're just get back to the P. Okay, now tell me, is there any operation is remain to be performed on node P? Yes or no? No. That means all V, L and R are cut down. So what we need to do is, we just need to get back to again parent node of P, and that is O. So we are just moving from P to O. Okay, so here it is. Fine. So now is there any operation remaining to be performed on O? Yes, that is right operation. Fine. So you just need to move towards the right side of O. So cut R, go to the right side of O, that is L. Fine. The next is cut V, visit L, and then move towards the left side of L. So cut L, move towards the left side of L. Okay, that is node E. Now here node E is again, students. Okay, first just complete the visit step. Okay, so I'm just visiting, cut down V, visit node E, put it down in our answer bucket, that is AOP, H, L and E. Okay, fine. That is, so now we know that E is a leaf node. So it is not necessary to go towards the left and right, or it is not necessary to check the left and right subtree of node E. So I'm just moving little bit fast over here. So there are no subchild, so just cut down L, then cut down right R. So now once again V, L and R, all three operations are performed on E. So we just need to get back towards the L. Okay, now is there any right subtree of L? No. That means cut down R of L and then move again from L to O. Fine. So after it, I'm just moving again from L to O. Fine. Just check the O. Check the O. Is there any remaining? No. So what to do? Let's move forward to the parent node of O. Now, who is a parent node of O? Students, A is a parent node of O. Just get back to the A. See, V is performed, L is performed. Now we have remaining operation, that is R. So let's move towards the right side of A, our root node. So here it is, cut R, right side of A, that is node F. So what is the very first operation we need to perform is V, that means visit. So visit F. So I just need to visiting the F and write it down in our answer bucket and move towards the left side. So cut left and move onwards the left side of F. So that is J. Now again J, visit J. Okay, so I'm just visiting it, write it down in my answer and then check for the next operation, that is L. L means left. Okay, is there any node on the left? No. Okay, so what to do? Just take the next operation, that is R. Is there any node on the right side? Yes, we have. So just go on the right side, that's G. That's G. Fine. Now see, G is again the leaf node. So first just completing the visit step. So I'm visiting G and then write it down in my answer bucket. Okay, and now what we need to do? What we need to do for the rest of the operations L and R? So just I am going to cut it, both of them, cut L, cut R, because there are no elements at L and R position of G. Now see, here V, L and R, all three operations are successfully done on node G. So we can directly move towards J. We can directly move towards J, from G to J. Okay, fine, from G to J. Again all operations are done on J. So let's move further for the node F. So node F is over here. Okay, from J to F, and the last is check any operation remaining or not. Yes, on F we have to move towards right side. Okay, so here it is, from F to Q. That is first visit, then L and then R. Why? Because Q is leaf node. Fine. So up to now you can see that each and every node I have visited, yes or no? Yes. But in which sequence I have visited the nodes? I have visited each and every node. Fine. But in which sequence? As per pre-order sequence, where I need to visit my root node first and then go move forward to the left side and then take on the right side. If somehow in the middle, if my visit left and right, all three operations are successfully completed, then I need to get back towards my parent node. Fine. So here the pre-order answer is, if I choose pre-order for my traversal operation, then my answer is like this: AOPH, LEF, J, G and Q. Fine. So always remember that in pre-order we are visiting root node first, and in order students we are just visiting in root node in the middle of the terms. Fine. Or in the middle of the sequence of the nodes. Fine. So that's a pre-order traversal operation. You have to perform one example at your home, so we'll get the better idea from this. Okay, so that's it for today's lecture. Thank you so much, students.